Global Finance, Topic 17B, Global Portfolio Improvement. Copyright Lou Gaddis. So in this topic, we're going to look at how return or volatility improvements can be gained from going from a domestic portfolio to a globally diversified portfolio. So I left off in the last topic here. I did a little gathering of data, and I found that from 2003 to 2010, the S&P 500 had a 4% return with a 15% standard deviation. That gave it a Sharpe ratio, which is a measure of return over risk. It's actually the return of the portfolio minus the risk-free rate over that time, which I assume is about 50 basis points over the standard deviation. So that return over risk ratio for a domestic portfolio is 0.24. Over that same period, I constructed a portfolio that was 50% U.S., 40% developed markets, it's an EFA fund, and 10% developing markets, or an EMA fund. And that portfolio had a 7% return, 17.8% volatility. And when I computed a Sharpe, you can see it had a better return per risk ratio. And this Sharpe ratio is very important in finance. So the Sharpe ratio, if you can think about it, if my risk-free asset gives this rate of return, I said it was about 50 basis points, and I can invest in a portfolio D, which was, say, a U.S. fund, which had a 15 or 16% standard deviation and a 4% return, or I could have invested in a global portfolio, which had about a 7% return and a little bit higher risk. What you can see is that I would rather be investing on a line that it extends from the risk-free rate to G rather than a line that extends from the risk-free rate to D, the domestic portfolio. That's the S&P 500. Here's my global portfolio. If both portfolios start with the same risk-free asset, the line with the highest slope, which is also the Sharpe ratio, is going to lie above the line with the lower Sharpe ratio. And what we find is, at least to the data I collected, creating a global portfolio, the diversification benefit of adding developed and developing markets to the U.S. market allows you to get a better ratio of return over risk. So what that means is I can invest only in if I can only invest in treasuries, I'd be right here, no risks, low level return. If I can only invest in domestic portfolios, the S&P 500, I would be right here. However, I could combine, say, S&P 500 stocks with treasuries and get along on a point, say, right here, which would be, say, 50% S&P and 50% domestic. And then as I move in this direction, I'm starting to reduce my exposure to treasuries until I get to this point here, which is 100% domestic. But I can go to a point, say, right here, which would be, say, half my money in treasuries and half my money in that globally diversified portfolio. That's clearly better than this point here. So the trick in finance is to find a portfolio that has the highest Sharpe ratio, combine it with treasuries, and you can get it anywhere along this line here. So back to I'll do some examples with that line. You may have remembered from remedial or introductory algebra the equation of a line. If you have a y-axis and an x-axis, a y-intercept b with a slope of a line that extends from the intercept has slope m, we say that y equals mx plus b. So if I have a value of x and I'm looking for a point on this line, I can plug in my formula, plug in the slope and the y-intercept, and it'll give me y. Likewise, if I had a y value, I could solve this equation up here for x and see that x is equal to y minus b divided by m. Should be a division there. And you can plug in a y and you would get a x value. So in this problem here, we said, well, what if the risk-free rate is 1%? The slope of a portfolio is 0.4, except now we're going to use as the y-axis the return and the x-axis the standard deviation, which we do in finance. So now my intercept is the risk-free rate, that is the rate of return which is associated with no volatility, and my slope is by definition my Sharpe ratio. So if I have a portfolio that lies on this line, say here, but I would like to get a portfolio that has, say, a 10% standard deviation, which say is less than this point, I could get to that point by investing in both treasuries and that portfolio. And if I wanted a 10% standard deviation, I can use my equation of a line to compute the return of the portfolio. So in this example, the return on my portfolio is going to be the risk-free rate times the Sharpe times the standard deviation of the portfolio. In this example, it's 1% plus 0.4 times 10% standard deviation. That says that I can get a 5% return if I want a 10% standard deviation by investing in treasuries and this portfolio with a 0.4 Sharpe ratio. You can also work in the other direction. So we still have a 1% risk-free rate. Let's put that division back in there. We still have a 0.4 slope, but say you want a portfolio with an 8% return. What standard deviation can I achieve using this portfolio with a Sharpe of 0.4? Well, I can use my formula and say that the standard deviation of that portfolio, using this right here, is going to be my 8% minus 1% divided by the Sharpe ratio of 0.4. That'll give me 17.5%. So that's why the Sharpe ratio is important in finance, because it can tell you that if you find a portfolio with this Sharpe, you can invest really anywhere upon a line that extends from the risk-free rate with the slope equal to the Sharpe ratio. So back to our problem. I computed a Sharpe for US markets of 0.24 and a Sharpe of global markets of 0.38. Say I'd like a portfolio that has a 16% standard deviation. If I were to sketch out what my possibilities are, return, standard deviation, and say a risk-free rate of say 0.5% right now, I could be on a domestic portfolio line. We call these a capital allocation line, by the way. Or I could be on a global portfolio capital allocation line. Because of the higher slope, I know it lies above. So if I want a 16% standard deviation, I can get this level of return in domestic markets or this level of return in global markets. So let's go ahead and solve that problem. For a domestic portfolio that has a slope of 0.24, my return on that domestic portfolio is going to be, according to my equation of a line, using a 0.5% risk-free rate, of risk-free rate plus slope 0.24 times my desired standard deviation 16. That'll give me a 4.34% return. If I invest in global, I can get a much higher rate of return. So my return on a global portfolio, same risk-free rate, but I have a higher slope times my 16% volatility, I can get a 6.58% return. So we call this distance here a return improvement, which I believe is 224 basis points, going from a domestic portfolio to a global portfolio for the same level of risk. Now you might say that, well, that's not a lot of money, 2% a year. Well, if you started saving next year when you start working and put $10,000 into a retirement account for 45 years at a domestic rate of 4.34%, you can use your calculator. I would put present value equal to 0, the payment equal to 10,000, n equal to 45 years, my y or I equal to 4.34%, and then I compute a future value, and I have $1.3 million. If I invested in a global portfolio, I could plug in 658, recompute my future value, and what you see is you'll have $2.5 million, which is substantially a lot. That 2% per year builds very quickly over time. And my last thing I'd like to talk about is, well, we've determined that we definitely want to invest in a global portfolio. And we want a global portfolio with a 16% standard deviation. but the global portfolio has an 18% standard deviation, so I need to combine it with treasuries, a little bit of treasuries, and I can get to this point on the line. So let's try to figure out how to actually build that portfolio. Again, here's the global portfolio with a 7% return and 17.8% standard deviation. To get to a 16% standard deviation, I'm going to have to combine it with some treasuries and get to this point here. We know that when we combine a risk-free asset and a risky asset, which is what we're doing, the portfolio volatility, standard deviation of that combined portfolio of the risky and risk-free asset is going to be the weight of the risky asset times the standard deviation of the risky asset. So our total portfolio standard deviation is 16%. I'll plug that into that equation. The standard deviation of my risky asset is 17.8. I'll plug that in. And I'll solve this equation for the weight in the globally risky portfolio. And that turns out to be 90%. So to get to this point here, I would put, if I had $100 to invest, I'd put 90 in the global portfolio and $10 in treasuries. That'll get me to that point. And that's how I use treasuries and the risky global portfolio to allocate a capital anywhere along this line. Anywhere beyond my G would be borrowing money and leveraging G. Anything less than this point, the G, would be combining G with treasuries. So hopefully you can see how you can use portfolio diversification, or in this case just finding any portfolio with a lower Sharpe ratio, to improve your overall portfolio returns.